And welcome back, friends, to Cajun Coding. This is St. Raz, and we are still on the Codingbat website studying Java. We are in the Logic2 series of exercises, and we only have a few of these left, last three. And I believe we should be able to have plenty of time to do these and then progress on to the next series of exercises. I think we're just going down these middle two, the middle and the left row here. So we'll move on to String2s and then to the better, to the higher level arrays, and then maybe come back and grab maps and functions. So Logic2, Blackjack, and the description of the problem is given two int values greater than 0. Return whichever value is nearest to 21 without going over. Return 0 if they both go over. So this shouldn't be too complicated. Let me see. So let's try the return 0 if they both go over. So this is pretty simple logic. If A is greater than 21 and B is greater than 21, we just return 0. Simple enough. Else, if we could do an A greater than 21, we could use the exclusive OR here. B is greater than 21. Pardon me. And if you'll remember, using the exclusive OR, that means that one of those conditions is true, but not both of them. So if we know that one of them is over 21, then we simply return the lower of the two. And then our last case, we've already handled one of them is over 21, both of them was over 21, neither of them is over 21, so we return math max, the bigger of the two, A, B. The reason we're returning the lesser of the two is because the larger went over, and only one of them went over here. And if that's not the case, then neither of them went over. We'll return the larger of the two. And of course they actually did return a solution. They have a published solution for this one, and they used a completely different approach with this one. What they did was, first of all, they set these they create a value for A and for B. And what they do here is, if the value is over 21, they override that and set it to 0. And then they just use if else to return the value that is larger without going over 21. They just return the larger value because, remember, the over 21 is set to 0. So then, it being 0, then they just need to return the larger one. And actually they introduced the ternary operator here. And I don't think we've talked about the ternary operator at all. Let me see. But the ternary operator is used, and I'll just use this as a whiteboard here. The ternary operator is going to be basically an if-else, but we use the characters, the question mark, and the colon there. So it's going to be in the form conditional, or it should be value equals conditional. That's your statement that you're assessing. Then you put the question mark, and then the statement execute if true, and then the colon execute if false. And the ternary operator is a nice succinct way of putting it all on one line. The big things you got to remember here is there's the question mark and then the colon, and to the left of the colon executes if the conditional resolves to true, and to the right of the colon if that, oops, I didn't mean to drag that, the right of the colon is what executes if that condition is evaluated as false. So could have been using, I'm sure I've had plenty of opportunities to use the ternary operator. It just didn't occur to me to use that. Okay, let's try to remember that, and we'll go forward and try to use it whenever it crops up. Okay, logic 2, evenly spaced. Given 3 ints, A, B, C. One of them is small, one is medium, one is large. Return true if the 3 values are evenly spaced. So the difference between small and medium is the same as the difference between medium and large. Now, small, medium, and large, they're not necessarily going to be coming through in that order. You see small, medium, large, but then you see medium, large, small. So we might be looking at going ahead and sorting these out. So let's see if actually let's set up these ints: small, medium, large. If, let me see, if math max AB is less than C, then large will be C. Else we set large to math max AB. And then we're going to do this with the small with the appropriate changes. So if min is larger than C, then we're going to set small to C. Otherwise, we're going to set small. Okay, and if A is greater than small and A is less than large, then medium will be set to A. Else if B is greater than small and B is less than large, medium will be B, and the only other possibility, medium, will be C. And now that we've got that sorted out, return true if the 3 values are evenly spaced. So we just return the truth value of the statement math absolute small minus medium is equal to math abs medium minus, is it large or big? Large. It is large this time. Should be it. Yeah, there we go. Not bad, not bad. They don't give us an answer for this. I wouldn't mind seeing their solution. Is this too verbose? Yeah, it seems like, on one hand, it seems like there should be a simpler way to do this. On the other hand, these exercises are getting a little more complicated, so maybe, maybe there's not a way to make it a lot smaller. I'm sure there's ways it could be optimized a little bit, but you see the logic and how to execute that logic in the Java language. So, and on, I believe, yeah, make chocolate is our last one, and this is kind of riffing on our make bricks problem. We want to make a package of goal kilos of chocolate. We have small bars, 1 kilo each, and big bars, 5 kilos each. Pretty familiar so far. Return the number of small bars to use, assuming we always use big bars before small bars. Return -1 if it can't be done. So instead of yes or no, is it possible, they want the number value of these small bars that are used. Note here, this return -1, if it can't be done. A return value of -1 is pretty common in Java. There are a lot of methods that are built into the Java language that you may use. For example, index of. If you call index of on a string and pass in a character, it will return the index value of that character. Say you call index of on the string make chocolate, and then you pass in E as your parameter. It will return 3. This is 0 index, so 0, 1, 2, 3. I know there's an E over here. It actually returns the one that's furthest to the left. So it will return the index of the one that it is, of the first one that it encounters, reading left to right. Now, if you do the same thing and you call index of on make chocolate and you pass in the parameter Z, there's no Z here. What it will do is it will return -1. And that's a common feature of many methods that you'll be using in Java. And in this case, this is going to be a custom method, a custom function that we're writing. And this function we're going to write so that it returns -1 if the task we're given turns out not to be possible with the bricks that we're given. So do keep an eye on that. -1 sometimes means there isn't one, or we couldn't find it, or this isn't possible. So anyway, to the problem here. Assuming you always use big bars for small bars, return -1 if it can't be done, and return the number of small bars to use is our goal. Borrowing from a make bricks problem. So if big times 5 plus small is less than goal. Okay, what are we doing here? The big blocks are 5 kilos, small ones are 1 kilo. If we put all of our blocks together and it's less than our goal, then obviously we can't, it's impossible, we can't do it. So we're going to return -1. So that's one case in which it's impossible. Okay, else if, now let me see, if we take goal modulo 5 and that is larger than small. Now what is this saying? So if we take goal modulo 5, the big bricks are 5 kilos each. Now if we have a number like say 19, then 19 modulo 5 is going to result in 4. So we've got our 15 kilos in large bricks. So we've got 4 left. If the result of that expression, if we only have 2 blocks and we need 4 kilos left, we can't put another big block because that puts us over. Then under those conditions, it's also impossible. So return -1. And if neither of those conditions are true, then I believe it would be possible. So we need to just figure out how to return that. So under those conditions, if big times 5 is greater than goal. What's that mean? Big times 5 is greater than goal. That means that we have enough big bricks that we can reach the goal or go over the goal. So in that case, all we need to figure out is we're going to go just short, within like less than 5 kilos short of our goal, and then we have however many small bricks we need to make up that difference. So what is that? That's return goal modulo 5. Okay. Now, if that's not the case, for example, so if we don't have enough big bricks to do that, then let me see. So if we take goal minus big times 5, that's going to give us goal minus big. See, return. I think that should be it. Return goal minus big times 5. So if we take all our big bricks, which are 5 each, we subtract that from the goal, then that's how many small bricks we have to use. And there it is. And I did have to work on this one, more so than I had to work on any others up to this point. I did not have to look it up. I worked on it for a while. I didn't have to search for an answer. You guys can tell when I cheat if you watch carefully. Look up here. Sometimes I'll leave a tab open if I have to pause it and look for something or to make sure I've got something right. Then I'm not going to lie about that. That's no big deal. You know, people have to look stuff up. And but that worked out pretty well. So if you're confused about any of this, go over it a few times. But the logic for this is not something that you would have to learn over again. You have to learn the syntax and the conventions and a lot of the methods or built-in functions of programming languages. You have to do that with every language. Now, a lot of them are very similar. A for loop looks very similar in Java, JavaScript, C++. So there's not big differences, but there are small ones there. But the logic of how to work through a problem like this, that transcends language. If you can figure out what it is you need to do, this if statement, and then this if statement, and then this if else here, the computations themselves, that transcends language. You'd be able to, if you can program at all in Python, and if you've solved it in Java, then you'd be able to solve it very quickly in Python or in C++ or whatever you're using. So, but that's it for Logic2. And now going on, and we're going to move into String2. Medium string problems. It says one loop. So we may have some for loops and such. I don't think in the string 1 section, I don't think we had any loops. So given a string here, double character, return a string where for every character in the original there are 2 characters. And they said we can use loops for this. I wonder if they want us to use a loop. Yeah, apparently they are okay with us using a loop. I was trying trouble figuring out how we would do this without a loop, but it seems kind of strange writing a loop for just 2 iterations. But let's go ahead and set up our answer, string answer, and we're going to set it to empty. And our for loop for int I equals 0, I is less than 2. Alright, and for each iteration through here, answer is plus equal str, and that's our string we were passed in, and of course we're returning it a string as well. Str car at index I, and of course this is going to pass through twice for each, wait a minute, I'm not sure about that. Car I, you know what, that's not right. we're going to go through str length. Now for this, and then after the for loop, we just return answer, not string. We return str. It'd be the same. I think that should do it. Yeah, that should do it. Now, what I was about to do, this would mess it all up here. See, this would just do the first two characters, and then for short strings, it'd get out of bounds. See? Well, it works for this one, because it's only two characters. Yeah, so. But yeah, that's not what we want to do. We want to do that. There we go. Sometimes it's too easy, and then you just not paying attention. Okay, so count high. Return the number of times the string high appears anywhere in a given string. And I'm not going to look at the hint. Let's see what we got here. Okay, so let's do int count. We'll be returning an integer, and we haven't started counting yet, so let's go ahead and initialize it to 0. And now we're going to set up our for loop. Is it string length? Well, we're looking for a substring of 2 characters, so let's do string length -1. Okay, and for each iteration through that loop, we're going to look for if, let me see, if str substring, and then it's going to be I and I plus 2. Now we're using substring, so it's going to be equals, and then we put our substring in there. Oops, let me see, I, that's the end of the if. And if that resolves to true, then we increment our count. And that's pretty much it. Then we return count. And there we go. And what was their hint? Show hint. Yeah, just use the loop. Use the loop. That's not a hint. That's the answer. I mean, all you have to do is implement that. There's no problem solving or anything. But so these seem a little easier than the ones we've done just briefly, just a short time ago. Next one, cat dog. Wasn't that a cartoon? Cat dog. So return true if the string cat and dog appear in the same number of times in the given string. So let's go ahead and cat count, and then int dog count. And now we're doing a for loop. Go figure. Okay. Sometimes. Okay, so we're looking at one string. So this is going to be str length minus 3. Okay, so we're going to have if str substring I plus 3 equals cat count will be incremented by 1, and then we'll take this if block here, and basically it's going to be the same thing. It's going to be dog. And then we return cat count equals dog count. Let's see if I messed anything up. Oops, what did I do? Missing, oh here it is. I bet it's right here. Since I used cut and paste, now I've got two of them. This closing parentheses closes the call to the equals method, and this one closes the if conditional. And same, fix the same thing down there. And what's going on here? Why is that false? Now I've got some of these. Well, those are true because we don't have enough of either of them. Why is that true? Okay, so we initialize cat count and dog count. Length -3. If we bring this lower, I think we're going to get some out of bounds errors. Oh, no, that's what it was. I was off by one there. Length 2. Okay, so this is less than. So it would be less than or equal to 3 should work fine. Less than or equal to. See? Okay. Yeah, those aren't uncommon. So, less than, if you need the very last character, less than string length is fine. If you need the last two characters, it would be less than string length -1. If you need 3, less than string length -2. Now if you use the equal, then less than or equal to, that would put it off by 1. So there we go. Alright. Let's try one more before we end the video there. Let me see. Count code. Remember return the number of times that the string code appears anywhere in the given string, except will accept any letter for the D, so cope and cooey count. So actually what we're doing is we're doing two comparisons essentially. We're checking for a CO and then we're checking also for the E. We're not checking that third letter there. So this is pretty easy. So we'll go ahead and say return the number of times. So we're going to be counting. For int I equals 0. I is less than. Now this is a string of 4 less than, so it'd be str length minus, this is less than, so this is going to be 3 this time because this is a chunk of 4 characters. And we've got our incrementor there. Now if, let me see, str substring I plus 2 equals, and it's going to be CO, and we're going to check that other one, str substring, and this would be I plus 4. Or plus 3. Let me see. I be 1. See, I plus 1, 2, 3. It would be plus 3. Plus 3. I plus. It's up to, but not including 4. So it won't actually do 4. Oops. And we increment count. And then we return count. operator. That's interesting. First type Boolean, second type Java lang string, line 4. That's an interesting error. What's going on there? First type's Boolean, second type Java lang, see str substring. That is an interesting error. We can, bet we can go around this. We can get around it by using a nested if. And I'm kind of curious as to, pretty sure this would work. Line 5. Look at that, Mr. Parentheses, of course. Oh, it does not like that. See, Java lang string cannot be converted to Boolean, except that our equals. Oh, there it is. That's what it was. Darn it. Get to see me make mistakes in coding in real time here. Okay, so this is what we had before. Okay. Substring. This looks okay. We didn't check the equals. Okay. And equals the E. We gotta make sure we got the parentheses right there. Expected line. We still don't have the right number of parentheses. Okay, let me see. Is it really another one? Nah, I was just trying. Okay, let's break this down. Okay, so we did remove the and. Okay. Okay, let's put the ands back in there. There it is, and it runs. Now, if you're watching this and you're kind of confused right now, this is what happened. Okay. Oh, fun episode. All right. Okay, so I've got 2 bits of code here. Okay. String, substring. Now when we call substring on a string object, on that variable, okay, when we call a method substring, it's going to return something. Okay, in the case of substring, what it returns is a section of the string. And what it returns being a section of that string, literally a substring, that is data type string. So when we check on this, we look at this, it's looking for the CO, okay? Or actually it's returning the snippet of code there, that portion of a string, okay? But the return type is string. When we call the method equals compares this to something else, to the substring, okay? So equals also returns something, but when we call the equals method, the data type that returns is a Boolean. Either it matches and it returns true, or it doesn't match and returns false. When I didn't have the equals here, when it was just the substring, what I'm doing is I'm comparing a substring to a boolean. Comparing a string to a boolean doesn't make any sense, and that's why the compiler yelled at me. Of course, yeah, it's hard to say, well, would it have worked if the compiler actually took it and ran with it? That's kind of a weird hypothetical, so I couldn't say that. But that's the reason it threw that error, and that's why I had to do that. Now, what I was going for, and of course I wanted to look up that error and figure out what was going on, but what I was also going after, if I could take this, and I'll go ahead and clip this out. Okay, if that equals the CO, and then within that, if that resolves to true, what did I do? Expected. Oh, I don't have a parentheses here. Okay, this runs. Okay, what this does is I've got an if the first part that we're looking for, the CO is there, then we go on to the next inner nested if to see if the next part is there. And then if that's true, then we increment count. This is a totally inefficient way to do it. The only reason I was contemplating doing it that way was to see if it would change things up or whatever. And while I was in the process of doing that, spotted the mistake. But stuff like that, it happens all the time. So, but in any case, I hope that was entertaining and hopefully illuminating. We're almost 40 minutes here, and we're going to pick up code count and other is where we're going to pick up next time. We should be able to get through quite a few of these strings with loops in our next episode. Thanks so much for tuning in. Appreciate you guys, and as always, like, subscribe, comment, requests, questions are all welcome. Bye-bye.